So let me talk to you about doing these series circuit problems. Hopefully we're doing them together, but if not, here are some hints to get you through. Hopefully you're in a nice comfortable spot and maybe you're working outdoor on your tablet. Okay, so we're going to start out with two circuits that are actually the same circuit in different configurations. So we have a light bulb hooked to a dimmer switch. In the first case, the dimmer switch is set to 0 resistance. This should make the light bulb as bright as possible. In the second configuration, our dimmer switch is set to its highest possible value, which happens to match the resistance of the light bulb. We would like to figure out how the dimmer switch is going to change the current, the voltage, and the power to the bulb. So for the first one, you're just going to use I equals V over R. You can totally ignore the dimmer switch since it's set to 0 resistance. So use the voltage of the power supply, use the resistance of the light bulb, find your current, put it in here, have it flowing around your circuit. Then you can use that current to find your voltage because you know the resistance, and then you can find your power. The voltage should be the same as the battery since the light bulb is the only thing using up energy. Okay, and the second one's a little harder, but this is what our series circuit is going to be like. We do I equals V over R. For voltage, we use the entire voltage, and for resistance, we use the combined resistance of the two. So add the two resistances together and use that as your denominator. Once you get the current, that is the current that is flowing out of the circuit, and you should draw that current and label it coming out of the negative terminal of the battery. Then you take that and use Ohm's law 2 more times. Once for the variable resistor and once for the light bulb. So use the same current. Now instead of using the total resistance, just use the resistance of each component. Solve for volts, put it here, then use power equals VI to get your power. Do it again here, do it again here. Okay, and this will get you your values for when the resistor is set to the higher value. Put your work and your answers on this slide. Question 2, we're going to deal with a toaster, and we're going to start with an ideal circumstance where we ignore the wires that are bringing the electricity to the toaster. So for the resistance, we can just put in the resistance of the wires inside the toaster. And for the voltage, we plug in the voltage of our power supply. We then use I equals V over R to get our current. Power equals VI to get the power of our toaster. This is our ideal circumstance, but it will not match reality. So in reality, the toaster needs a wire running towards it to carry the electricity into the toaster. That wire will have resistance, and we'll assume that the resistance of that wire is 1 ohm. The toaster itself was 18 ohms. Combined, they're hooked up to 120 volts. So you'll notice the total voltage is 120. The resistance of the toaster is 18, and the cord is 1. Start by adding the two resistances together to get your total. Then find the current total by using the total volts and the total resistance. So this is step 1. Step 2, you get the current right here. For step 3, you just take that current and put it in both of these boxes. The current is the same for all parts of a series circuit. So just fill your number for current into all the current boxes. Then to find the voltage for the toaster and the voltage for the cord, use I equals V over R, using the current, and the resistance for that row. Okay, that'll be step 4, is getting these two. Then you can get your powers by doing voltage times current. You can do it for the toaster, you can do it for the cord, and you can do it for the total. Put a picture of all of your work on this slide, and then read through what I say about the importance of the extension cord's resistance. So I hope this made sense. Do the best that you can, and if you have serious questions, email me.